Hello and welcome back. In this video, we're going to talk about completing the square again, but in this particular case, what we're going to be doing is we're going to be looking at completing the square on an equation that has an odd middle term, okay? So whenever the middle term is odd, as you can see here, we have a -5 rather than like a 4 or a 6 or any even number, okay? It gets a little bit more complicated with the algebra. The method does not change, but the algebra and fraction work, it's a little bit harder for us to be able to work with. Okay? All right. So, same thing as before in the previous video. I reckon we dive straight into it. So, without further ado, we're going to move the constant to the other side. It's currently a -3, so I'm going to make sure that we make it a +3. So I've got x squared minus 5x is now equal to 3. Remembering that our aim on this left-hand side is to end up with a perfect square. Okay? So, what we need to be really, really careful with, because this middle term is odd, okay, we need to think about when I go and halve it, square it, and add it to the other side. Okay? So, if I think of the coefficient of 5, to go and halve it, essentially halving means to divide by 2. Another way of writing that is to write it as a fraction. Okay, so I end up writing that as -5 on 2. Yeah, so halving it, I'm going to half the coefficient here. Okay, half of -5 is then going to be -5 on 2. I square it and I make sure I add it to the other side. So I halve it, square it, I add it to the other side. That's the only slight bit of increase of difficulty for this particular example in terms of making sure that I keep track of what I'm halving, squaring, and adding to the other side. From here on out, now all we're going to end up doing is playing with a little bit of algebra, okay, and some fraction work, okay? So on the left-hand side, we're probably not going to bother with this just for a little bit until we tidy up the right-hand side. You have a calculator, and I actually would encourage you to use your calculator for this particular next step, making sure that you include the brackets. Okay, so plugging this into your calculator, you should end up with, once you've done 3 plus 5 on 2 all squared, should end up with 37 on 4. Okay, now it is no different from this particular point onwards to go and unlock the perfect square and then get x by itself. A note before I move on. You will notice that the denominator of this is currently 4, and the denominator of this inside of the perfect square is currently 2. I want you to watch what happens, okay? Alrighty, so let's go and unlock this perfect square. I'm going to take the square, move it to the other side, and I'm going to take the square root. So x minus 5 on 2 is now equal to plus or minus the square root of the entire fraction. Okay? Now remember, when we're taking the square root of something, that's the same as us as applying a power of a half, which means that the square root can be applied to the numerator and to the denominator independently. Okay? So, x minus 5 on 2 is equal to plus or minus the square root of 37 over the square root of 4. Okay? You can, of course, plug this into the newer style of calculators, the 82,000s, rather than the older style, and it will do this for you, but it's still worthwhile for you to go and see. You'll notice the square root of 4, as I mentioned before, now simplifies down. So x minus 5 on 2 is equal to plus or minus the square root of 37 all over, and the square root of 4 will become positive 2. Now, why does this matter, and why do we want to go and apply the square root in this particular step to the top and the bottom? It makes our answer look a little bit more nicer and aligns more closely with the quadratic formula. Okay? All right. So now we're going to get our x by itself. So we're going to move this 5 on 2 to the other sides. Now I'll just show you in an extra step. You can do this slightly faster. Okay, x is equal to now positive 5 on 2 because it was a negative here, plus or minus the square root of 37 all over 2. And why this makes me happy to go and see answers put in this particular format is the fact that I am now adding or subtracting fractions with the same denominator. So if I'm adding or subtracting fractions with the same denominator, I can now combine the tops and the denominator remains the same, giving me that as my final answer for completing the square. Okay? In the next example, and that will be the final video, we'll cover where we do a non-monic completing the square style question. Okay? Thank you very much.